How many people in here are not like graphics folks employed by like Intel or NVIDIA or whatever else to work on stuff? So, good number of people. Okay. So, I am one of you. Anyway, my name is Matt Du. My handle is Marcos. So that's me. I actually work for Micron. I'm not here in an official capacity. I'm actually here on my own, so I don't speak for them. Standard disclaimer. I'm just here on my own. But I did get a chance, I got permission to talk about how we actually do some hardware development at Micron and controllers. It's ASIC development. In essence, we ended up pulling a bunch of stuff over from software to help out with hardware development. And so that's what I'm talking about. All right. Oops. Oh yeah. So I work in a verification group, Micron, hardware guy. Hang on. Oh, I got that out of the way. Okay. Hardware development. Y'all know what this is, right? It's just simple ANDs and OR gates. Does anybody think that hardware development is still done with these? Nobody? All right, okay, just making sure. Yeah, because otherwise ASICs are huge, so yeah, we don't do that. So what we do is we use HDLs, hardware description languages. That's the same thing those gates are, just in text, like C, right? This being the majority of the excitement of this. So that's pretty much how all ASIC development is done now in this language. And it uses similar tools to software. We got compilers, we got synthesizers, all of which operate on the source code here. So we can track it in the same way that software does. We happen to use Subversion, not Git. Doesn't actually matter, it's just what we use. So, that being said, okay, in my division, we have similar problems considered to a large software group. We got 150, 200 engineers all working on a project, and we're basically spread out all over the place. It's not like we sit in one location. So we have the same communication problems that large software groups have. Different time zones, sometimes completely across the world, communication issues, how do we work together to get stuff done. We also have different areas we have to work on. It's just, we're not just writing the code that has to go in a compiler and work. We have like FPGAs, ASICs, we got to do simulations. So we start with the same source code, but we got to run it through different tools. And those are some of the tools. The tools don't always play nicely together either, so we have to take that into consideration as we're doing a lot of the coding. Let's see, but we also want the same thing that software folks do. We don't want to have to duplicate the code a lot, right? We want to use as much as possible for the exact same reasons the software folks do. Let's see, yeah. But we also see a lot of the same problems. People stepping on each other, duplication of code, maintenance, et cetera, et cetera. And we found out that as the code base grew and the number of developers that came onto the project and projects grew, we started running into some problems. It got us into some issues. So we borrowed a couple things from software folks to help manage that. One of them was gated trunk. Places like OpenStack uses it as well. So that's nice. And then DevOps, which is basically just kind of closing the loop, kind of tightening the feedback loop between groups. So gated trunk, it's known by a couple names. Read-only master branch, I think, is kind of the common Git term. And I've heard it called preemptive continuous integration and project gating as well. So all things, I think they pretty much mean the same thing from what I can tell. So what is it? Basically, just like what it sounds like. You're not allowed to commit to the main line. You got to work on development branches, do all your work there, and then when you're ready to merge it back in, you got to go through a gatekeeper. Pretty simple, pretty straightforward. Now, since we obviously want the whole thing of where we can use each other's changes as quick as possible, we still want to make sure the branches are short-lived. You don't have a branch that lives forever, right? You mainly want everyone working on the same code base so you can see each other's stuff. So you got to worry about that. Basically, merging your branches back in the trunk as quick as possible so everyone else can pull them down and use them. So why? Yeah. For basically what I just said. We really, really want to be able to have a stable trunk that everyone can check out at any time and be able to work on it. It's less useful if they can check out the code base and it doesn't work for them, right? It's less useful than if they actually could use it. So we want that. But we still want to be able to commit early, commit often, right? There's some good things there. So we want to be able to do that. And code use. Yeah, we have multiple projects, just like in like OpenStack does, right? You got a bunch of projects that are related, and they're kind of sharing amongst each other. So we have that as well. So we want to be able to reuse things between each other and use each other's stuff without breaking each other, which turned out to be an actual real problem. So yeah, we started with a simple continuous integration, which worked pretty good. Yeah. And to get that going, though, we had a simple honor system pre-trunk commit. Hey, before you check your stuff in, run this suite of tests just to make sure we're all good, right? Worked pretty good when the group was small. But then we started running into problems as the group grew and the code base kind of grew a little bit too. Race conditions. People would try to, hey, it works good, and they'd go to check it in, but someone else had done the same thing and just barely snuck them out, so then all of a sudden they break each other. Another issue is managers who would say, I need this done, I need it in now, so they can check it off and move on to the next project. Same issues that software people have. Another issue is if it takes too long to check stuff in, that pre-chunk, your pre-commits check suite, if it takes too long, sometimes people just stop using it for various reasons. I got to get this in because of my manager, or hey, if it breaks, I'll worry about it later because it's quick, et cetera, et cetera. So we started relying on, we'll catch it the next day to get things fixed. A bigger issue is, this one. In the hardware world, we're limited by licenses. So I know in this you can run GCC and there's no real limit to the number of times you can run it. It's just basically the number of processors you got. When you're doing hardware, basically the tools, most of them require licenses to run. The licenses are not cheap, so there are a finite amount of them. So if you want to run your sims and you got 50 other engineers also wanting to do the same thing, we all got to share. And so what that essentially does is it slows people down from getting their work done because you got to wait on things. Well, if you're having to wait for licenses because other people are using them, then that runs into the running of your pre-commit suite. Right? It's like, wow, this takes too long. So in other words, I want to get my stuff in, I want to run my check suite, but I can't get any licenses. I got to wait until the licenses free up. So what it does essentially is it ends up pushing out how quickly you can get your stuff merged in because you got to wait longer to get stuff. That becomes a bigger issue the bigger the group gets. Like I said, the licenses are not cheap. Yeah, so what happens? People bypass the checkers and they just start checking stuff in, and we end up stomping all over each other. Leads to a lot of frustration. This is actually the Oscar Blues Tap House. It's luckily right next door to where I work in Longmont. So we spend a lot of time there. After work, of course, after the work is done. So yeah, that's our Trunk Mangler support group. So what we ended up doing, so for the trunk checker, we use Jenkins like pretty much everybody else these days. And we set it up so that Jenkins actually can commit to the trunk, but no one else can. We mark the trunk as read-only except to Jenkins. Branches we made globally read-writable, so you can go to town on those all you want, but trunk is special, it's locked down. So in order to do that, you work on your branch, and then you basically go to a Jenkins page, and there's a drop-down for Jenkins, and you select which branch is yours that you want to merge, and you click submit, and possibly like a commit message or something else, a little note, and then it queues up a merge. And what it does then is it checks out a fresh workspace, and then starts running through the check suite, and then if all that passes, all the checks pass, then Jenkins will merge your branch into trunk and then toss away your branch. Keeps things all nice and neat, works pretty well. So we started this before there was actually a Jenkins plugin to do that. There's a Jenkins plugin now to do that. We haven't looked into it much yet just because of lack of manpower. So we still kind of use the old because it seems to get the work done. There's also something called Zool, which OpenStack uses, which also seems to be relatively similar. It looks kind of cool. I just haven't had any time to look into it. Let's see. One of the other things we do is that because of these gate checks are important, the engineers keep the list. It's not like there's a separate group that says, these are the golden tests, y'all have to pass these in order to get your stuff checked in. The engineers who are working on their stuff, they're the ones who determine the tests, because if the projects don't work, it's engineers' butts on the line. So it seems kind of good to make sure they're involved. And also the tests change depending on where you are in the project. If you're at the early stages of the project, you can be a little more lax. If you're at tape outs, you want to be very, very strict because tape out and ASICs are kind of expensive. There is an NRE, non-refundable engineering cost, when you go to actually tape out silicon, non-refundable. So if you bork something, you just throw all that money away. So you got to kind of be strict when it's at tape out. So, yeah. In addition to it, I said previously I mentioned there's several groups, not just simulation. We've got validation groups, the FPGA validation groups. We've got our simulations, which is DV and E designers. That's what we do. ASIC, these are the guys who are going to do the tape out. So they've got their own checks that are different than FPGAs. Now you notice there's two different synthesis checks here, FPGA and ASIC. Even though it's the same code base, they're different tools. So even though it might be valid for this tool, it may not necessarily work in the other tool. I don't know if a rough equivalent would be ARM assembly versus x86 assembly, where you're starting from the same C code, but they're kind of actually different under the covers. You might be able to look at it like that. Say again?
Big Indian versus Little Indian.
There we go. So yeah, so we have to check it against both, which is in the beginning caused a little bit of frustration because if the RTL designers are more used to ASICs, they code in a way that's potentially more friendly to the ASICs, but may forget to go over and talk to the FPGAs and make sure it'll go through their tools, like Xilinx or Quartus. But if the RTL guys are more familiar with the FPGA, they may not keep in mind the ASIC guys, and the tools got to go through that. So basically, we have to say, okay, anyone who's touching the code base or is going to be involved in this, we put a check in the system that they got to get through. Keeps the code base clean and consistent for everyone. It's a little more work up front because it kind of pulls the work in. It pulls the pain in, but in the end run, in the long term, it actually ends up saving us quite a bit of pain. So, and then firmware checks, coding style checks. Another one we did was system resource checks. Basically, if you're running a simulation or whatever and you need just too much power to run your sim, you need gobs and gobs of memory to do what should be a relatively simple check, or you're using a lot of disk I/O because maybe you're using temp files that you may not actually need to use. We catch that because, like I said, if you've got 100 people working on something and everyone's writing in potentially really bad code, you're just going to end up causing more problems. So we also try to put checks like that in to kind of pull the pain in, catch all that as early as possible. Saves us in the long run. So yeah. And then dependency checks are, yeah, weird dependencies. So yeah, these are the types of different tests we run in our pre-trunk. Now we use this along with CI. So we use the pre-trunk, the pre-CI, as well as CI and like nightly regressions, and we kind of balance things around. We have hooks that actually kick off and queue the CI jobs, so that's all automated. But yeah, one of the main issues with how to balance these tests are when do you do them? We can't run everything all the time. It's not possible, right? Time limits, license limits, things like that. So it's basically a continual conversation of what do we want to check when, whether we want to do it up front out of the gate, whether we want to do it after it gets committed like CI, or whether we want to worry about it in our nightly or weekly regressions. So, and that's a continual conversation. And we improve and change tests depending upon things, right? It's a continual process. So it actually does help quite a bit. We found that back when we were just using CI and after the fact, we were breaking trunk all the time. At least once a day it would be broken. And sometimes the breaks actually would kind of stack on top of each other. So someone would make a break and someone would then check something in based upon that break. And then when you tried to go fix it, you're kind of stuck in a nasty little catch-22. So putting checks like this in up front completely they block that. So now we don't have to worry about that. So our trunk breaks went from daily to once in a great blue moon. So it was very, very helpful, but it didn't solve all of our problems. Nothing ever does. There's no silver bullets. So the next one, DevOps, another thing we kind of snatched from the software world. Anybody here know what DevOps is? Few people? All right. Sort of. Okay. It's basically shortened. It's a contraction coined in an Agile conference called Between Development and Operations. The short of it is basically start talking to people more often, anyone who might be involved, pull in the feedback loop, and you can use it to get stuff done faster, right, to get your product shipped because you shorten the feedback loop, there's more open communication, there's none of the silo where it's back and forth over the walls and whatnot. And also, number two is IT folks using some development stuff. They also borrow from software. So things like continuous integration, they got their build environment or whatever else, right? They use, and they tied in with Salt or Chef or Puppet or stuff like that. It's all kind of, what they do is they make their changes and then they push them out. IT also goes to this more iterative, push it out and deliver faster. So there's two parts to it. We mainly use number one because the whole point here is to get an ASIC taped out. That's why we're being paid. That's kind of why we're here. So anything we can do to pull that in, obviously, is of great interest. We kind of get number two as a come along, just because the stuff that speeds us up, IT can borrow and we can work with IT, and it speeds them up as well. Everyone benefits. Part of it, there's two things on top of continuous integration, which I'm actually looking forward to Mark Rand's, your presentation later. I'm looking forward to that. After that, there's continuous delivery and continuous deployment, and they're technically different, so I thought I would include them. Continuous delivery means you can take your code base and deliver it at any time. There's nothing special about a delivery. At any point, someone can take your trunk or your main branch and run with it. Say, deliver it and use it and ship it to customers. That's delivery. Deployment is that you actually deploy it. So delivery means it's ready. It could be delivered, but it doesn't mean it is delivered. Deployment means, okay, we're actually going to push it out and use it. You probably don't want to do that when you're shipping to customers, at least we don't. So we kind of use it in the IT stuff. We can make environment changes or whatever else in the build flow and whatever, and then we check it in, it runs through the tests with Jenkins, and it just gets delivered. So we have basically dynamic updates and immediate updates to our development environment. We use them both. One of them mainly just deployment we just use in the environment, because like I said, we don't want to push our ASICs out. And continuous delivery, basically the same thing I said before, so we can just run all these checks to make sure the code base stays good for everybody. And deployment is mainly used for rolling out environment updates. We do module pre-compiles and vendor updates like that. It also means pulling IT into the party. We don't treat IT as a separate group because we kind of depend on them. IT is important. They set up the environment, or they set up the servers, they help with the environment. If you don't have computers, you're not really going to get much done. So making IT as part of the conversation actually helps us quite a bit. I'm in the IT guy's office pretty much every day, just like with the other engineers. Hey, servers are running slow, or I can't do this, or I can't do that. Hey, yada yada. It's more than just like filing a ticket or just talking with the IT guys like I'm having a problem. It's actually sitting down and having real conversations like, here's what we're seeing. Can you help us? How can we work together on this? It's more than just get back to me later on. It's like, hey, help me solve this problem. It really is they're part of the group. I guess that was my presentation. Hang on. No, I'm missing slides. Oh, there we go. Here's some examples of a few of the things that we've seen pulling IoT into the conversation. Basically, IS sometimes they just want to give you like hardware. Bigger, better, and faster is better, just because it's an easy solution. And sometimes it is. Sometimes it's a nice, easy gimme. It doesn't always work. Right? Sometimes if your problem isn't, if you're not CPU limited, then giving you more servers isn't going to help you. If you're not I/O limited, then giving you a faster network connection or whatever, that's not going to help you either necessarily. So it's much more of the, hey, get back to me on this. It's like, hey, let's solve the real problem. So on this, we can pretty much saturate anything our IT group gives us. So bigger, better doesn't necessarily help us, especially when licenses are involved. Let's see, System Verilog. This one I kind of like. This one shows the real thing. Basically, in System Verilog, we can do packages and classes just like in Java and whatnot, but package imports are expensive. And we didn't realize that in the beginning, so we basically treated them like PEZ. We just put them everywhere just in case. It made copy-pasting code blocks and just made it nice and simple, but there's a cost to them. It slows down pretty much across the board. Compile times, but as well as optimization and simulation time. And we didn't notice that until we started looking into why is it running slow. It's easy to say, oh, your compilers are taking too long because you're trying to compile 3,000 files. Well, some files take longer than others. Why? Right? So you start looking into it, and you use that combined with your server monitoring. You watch your server load go up and down. You can kind of track down to what's actually going on. It's like running IO top or something like that, your systat stuff, pulling that into basically your development. If I code like this, execution time takes this long. If I code like it's profiling, basically, right? Just a little more system level profiling. So that, and then IT gains as well, because sometimes engineers, we can get a little lazy with not cleaning out our work areas. It's like, I'll just leave it there because there's, disk space is limitless. We'll just keep stuff there, and if I ever need it again, we'll just come back and get it. Well, IT's got to back all that stuff up, right? That's usually part of the corporate culture is all your stuff, your design files, whatever else, it gets tape backed up every so often, usually full backups once a week or once a month and incremental backups. Everything that's there, it may not get pulled into the incremental backups, but it will get pulled into the full backups. So if you're not cleaning out your workspace, you're just chewing up space and actually wasting your company's money. So we kind of pulled that in as well. And then some of the things we saw actually were counterintuitive. And that was kind of nice to say, that shouldn't work. That doesn't make any sense. Here's what the data is showing. It actually does work quite well. And we didn't see that until we kind of closed this loop with IT. Here's some of the gains we saw from doing all this. We used to do commits on SVN. It took around 15 minutes because we were using a NetApp that was way overburdened. And so once we actually got into that and found out what was going on, we actually dropped that down from 15 minutes to way less than a second, 80 milliseconds or something like it. Rather noticeable, right? It was kind of nice. It really was. The System Verilog package stuff I talked about before, it would take like 12 seconds to compile. We cut that down to, again, less than a second. Well, that's just because, like, hey, what's going on? Actually paying attention to what we're doing. And then here's a nice one is the NAS usage, the NetApp. Before that, since we weren't being as diligent in cleaning up our stuff as we could, we were chewing up 14 terabytes depending, because IT had their settings, we had our usage, and we weren't really talking as well as we should be about, hey, what is actually needed. So we said we got better about checking in and cleaning our stuff, and then we basically cut our usage down from 14 terabytes to under 1 terabyte. Everyone wins there. So these are some of the things that we saw. If I had to summarize everything, our biggest benefits is just because we started talking to each other. It seems silly, or not silly, it seems very obvious. And it is, but it's amazing how easily you forget that when you're in a day-to-day grind of just trying to get your job done. You don't step back and say, hey, so-and-so down the cube is kind of working on something similar. If I go talk to him, maybe we can actually do that. It's real easy to forget that in day-to-day. So, yeah, how does this apply to X? It's hardware development. It really doesn't. But the development itself might. Some of the things we learned that I kind of presented here, I don't know, maybe it'll plant a few seeds somewhere, and it's kind of my way of giving back to the project since I'm not a graphics guy yet. So yeah, that's my presentation. Any questions? You? Oh.
To me, the Jenkins setup that you were using sounded a lot like Garrett.
Say again?
To me, the Jenkins setup that you were using sounded a lot like Garrett.
It is, from what I hear. It's Garrett is much used for code review as well, isn't it?
Yeah.
Yeah. We've got a different, and I can't think of what it's called at the moment, that we use. But yeah, it's. I didn't put that when I mentioned Zool. Garrett was kind of. Could be included.
So are there any reasons for not using Garrett? Is it just due to it being Git-based, or?
Probably lack of manpower. So in this flow, the engineers, because we kind of did all that, we don't have a different group of people who can do all this for us. It's kind of the engineers doing stuff as we can. And so it's, lack of manpower really is why we haven't gotten that far. Right. Hopefully we can get to it, and then we can just use what's already kind of out there and do that. That would be nice, but yeah. Lack of manpower.
So how often do you actually generate new silicon based on your you're checking?
It depends on the place. So there's multiple projects going on, so it kind of depends on which one.
And if you're having this sort of continuous deployment, do you end up with a lot of variations of silicon out there in the real world?
Again, it depends. Some of this I'm not sure what I can talk about, so
Okay.
I got to be kind of vague. I'm sorry. I can tell you that doing this, we're able to get a really large ASIC done faster than any other group in the company. Again, that's probably too vague to tell.
Yeah,
you
so
much.
I'm thinking particularly from the software driver point of view, do you end up with like drivers that need to know this is version 1008 and that's different from 1013, which had a fix that happened in between, or?
You're talking about software.
Well, so talking about, so if you speed up your development process and your deployment process in hardware, does that make it harder to write drivers to support that hardware?
I'm sorry, I didn't hear.
If you speed up the development process for your hardware designs, does that mean it's harder for drivers to support potentially tens and hundreds of variants that might actually be out there?
It's a conversation. So on the hard drive, this is for specifically here, use it for controller ASICs. So it's all internal software. So since the software group is internal to the company, that conversation is a lot easier
So
to have.
they're in the
much
same
quicker.
step as you guys.
Yeah.
Okay. Right.
So it's much easier than having to deal with ISVs or whatever to try to make sure the drivers are up to date.
Sure.
That would be a very interesting conversation as well, but not one here. I'm in the back.
So is this like kind of a done thing, and you've found all the problems, and now you've got a process you're totally happy with, or is there like a next project in this line that you'd like to be working on? What's missing? What's next?
There's always something new. This has been in place for about 3.5 years. It's not done. There's holes, there's bugs, there's always room for improvement. And like he mentioned, there's Garrett and Zool and kind of like what OpenStack is doing. Hopefully we'll have some time to look into that and see if we can kind of leverage that rather than having to maintain our own stuff. But yeah, we're far from done.
Do you have somebody in particular that's responsible for the DevOps role of making sure this, like, that the development suite, that's you?
That's me.
Good work.
That's on top of my verification work, so yeah.
I'm curious how often submissions are rejected, and then because it seems like developers would maybe run the test suites before submitting also, right?
Yep.
And also if there's spurious rejections, like, you know, if the test suite is not 100% stable, you know, how often does it get kicked back, and then it's just a hassle for developers?
I don't have the breakdown of the kickbacks, but failures happen. You're not talking about just like test failures, like, hey, your code is bad, you're not getting in because it's
Saying
you're
like
talking
the
about,
code is right, but the test is wrong, maybe,
yeah.
or yeah.
It happens, I don't know, I can probably say a couple times a week, depending. It kind of ebbs and flows, because sometimes you'll get things like Jenkins will just wig out on its own, right? So that would count as a spurious interrupt that I have no control over. But maybe less than a couple times a week. So between a couple times a week, a couple times a month, it varies. So how often do you, because you use Jenkins and your CI stuff, right? How often do you see problems?
So we have like thousands and thousands and thousands of tests, and so and we're also running on old laptops, so it's a continual process to try to eliminate the spurious test failures, but we don't have such a severe impact when they fail. I mean, developers can look at it and be like, that's not me, and there's only 3 of them to look at, hopefully, across 500,000 tests. So but yeah, it's a problem, and I think trying to get to the point where the test suite is so good that you would actually, you know, kill part of a developer's day based on the test, right?
Depending on what the error is, yeah, like so they'll waste time trying to track down
right,
a non-real error.
or they just have to submit again and wait for it to finish.
That
right?
does happen.
Yeah.
We found it does flat out pisses some people off because they've wasted or they've lost a certain amount of time.
Right.
But it happens rarely enough that there's not like a whole lot of screaming. It's I guess an acceptable pain. And if any of my coworkers ever see this, they'll flat out disagree, I'm sure. But
Okay.
it's yeah.
So, two questions. First one's quick. How many commits a day, roughly?
It de- couple. I'd say probably a dozen. It kind of averages. Our commit suite is it takes between 90 minutes and 4 hours, depending upon where we're at.
Commit suite means like running the tests, or
No, you mean commit would be the Jenkins job merging a branch into trunk. Is that what you mean, or do you mean commits to the branches?
merging a branch into trunk.
Yeah, it's probably a dozen a day.
Dozen.
Or less, depending.
The other question, I'll guess because you didn't say it specifically. Did you try anything in between the honor model and the pre-commit CI that didn't work?
Such as?
You tell me. Like, did you go? Was that the direct? Like, okay, we have this honor model, and now we're going to do this pre-commit CI thing, or was there stuff in between?
I'm trying to remember because that was a while ago. I think there was some things in, but we didn't. We obviously didn't go very far down them. I can't remember. It's been a while if we did or not. Yeah, it's the engineers and me doing it, right? So it's like, well, I got this work to do. I got my manager telling me I got work to do. This seems to work. Okay, we'll go with it. Hopefully, if something later pops up that's better, well, we can shift to it.
Trying to figure out what doesn't work.
Honor system works in a small group. Once you get certain large, it doesn't work. But again, if you can prove me wrong on that, let me know, because I just want a process that works. So.
Us too.
All right, thanks.